You do.
Get that on the wall.
Yeah.
Just a new job.
Good morning. How you doing?
There, I am doing fine.
All right. We're a couple minutes out. We're a couple minutes out. I'm going to go call CQ in the flea market room and see if I can drum up some more business.
Okay. Morning, guys. Can you all hear me out there?
Yeah.
Yes. All right. That sounds good. Up here comes a customer. I just usually holler out into the hall, free beer, and that brings everybody right in. I have my helper here. Here we go. There. Up. There you go. Hi. Maybe she'll behave herself here. Likes to be where the action is. Mm-hmm. How's things at Hamcom this morning? Lots of good stuff.
Yeah, that's good.
All the bargains already gone. The best bargains are the ones under the table, that big box of wire that they just wanted out of the garage for $5. You know, it's got like $800 worth of copper in it. That's a good one. Hamfest are really just inter-garage transfer facilities anyway, so. There we go. Got another one coming in. We got a few customers online. It's almost time, so I'll just go ahead and kind of start the tape rolling here. This is my commercial for Ham Radio for Dummies. I don't know if here, I'll turn it around so you can read it in the right order. My video is backwards, but put that one out as 4th edition. So if you know anybody that just got into ham radio or is asking you what is this? Are you guys still doing that? That's what the book is for. So that's my commercial for the day. And I'll go ahead and start sharing my screen here. And we'll put, we'll even show the slides. How about that? Come on now, slideshow. Here we go. From the beginning. Okay, you should have a full screen grounding and bonding slide. Is that right?
Yep. Looks good.
All right. Well, let's get this show on the road then. This talk is about grounding and bonding. I'm focused on home and mobile stations. Primarily, it's an HF talk. This was originally given at Contest University and has been steadily evolving ever since. The goal of the presentation is to discuss what ground and bond mean. We use the words a lot. We don't use them very precisely. They have a lot of different implications and meanings. And then we've got a really wide range of requirements to deal with in the ham station. And ham stations are one of the most difficult to deal with because we deal with AC safety, we deal with lightning protection, and then all this RF up into the microwave spectrum. So literally DC to daylight. So each general frequency range has different requirements. So we'll talk about what you're trying to accomplish with grounding and bonding for each of these regimes. And then this is not a cookbook talk. It's too complicated. There's too many different circumstances to say, step 1, do this, step 2, do this, step 3. Doesn't work that way. So this is kind of a toolbox talk where I talk about the requirements and then techniques and the various issues that you come up with. And you go home and you go, okay, so that's what he was talking about. Here's my budget. Here's my circumstances. What can I do? And one of the important things I want to keep coming back to is one common, well-done system satisfies all these requirements. You don't have to have an AC safety grounding system and a lightning protection system and an RF management system. They are all basically the same problem, and you can deal with it with one system. You build it right the first time and it'll take care of you. There are some special issues associated with mobile stations, and I'll touch on some of those as well. And there are comprehensive resources at the end of the talk. If you would like a copy of the slides, including all the URLs and all that stuff, you can email me at my qrz.com address. Be happy to send you the PDFs. So it's not copyrighted, and you can basically do whatever you want with it. There's a lot of good reading material for the interested reader. Now, the ham radio references, the ARRL handbook and the ARRL antenna book have a lot of this material in it. Since I was the editor up until the most recent editions of these things, I was able to get a lot of the material into the book. It's condensed. You'll find it in the ARRL handbook back in the building a station and in the ARRL antenna book building antenna systems chapters. Ron Block in R2B is one of the Polyphaser original guys, and he wrote a very good series of articles in 2002 QST called Lightning Protection for the Amateur Station, where he discusses what lightning is and how to plan for lightning protection. These are publicly available. They're on the ARRL website. You do not have to be a member, although I hope you are. You can go in there and search for this and it will come right up. K9YC has written a number of really good tutorials over a wide range of topics. And Jim has 2 that I recommend all the time. First one's called Power, Grounding, Bonding, and Audio for Amateur Radio. Sounds like my talk. He really gets into it from the perspective of a retired audio engineer and active ham. His second is the Ferrite Bible for hams, RFI ferrites and common mode chokes. Just go to k9yc.com/publish or just Google K9YC tutorial and you'll find it. W8JI, Tom lives on a mountaintop in Georgia with 300-foot tower. And so he knows a lot about grounding and bonding and lightning. So his website is another resource for you. And for mobile stuff, the best website out there at the moment is K0BG, Alan Applegate, k0bg.com. So those are the good ones. And then I'm kind of partial to this guy, Grounding and Bonding for Radio Amateur. It's not a big book. It's about yay thick. The goal was to collect a lot of the information that was out there for AC wiring and lightning and dealing with RF in your shack and all that kind of stuff. The information was dispersed. It was very difficult to find out what to do and how the different types of recommendations related to each other. So the book brings them all together. It was reviewed by a number of experts, including Ron Block and Dale Svetnoff, who's another lightning consultant out of the Midwest, plus the ARRL lab and Jim Brown. And so those guys were really good and kept me out of the weeds. So that's a big endorsement from those guys. So like this talk, it's a toolbox for you, but it covers a lot of the issues and hopefully explains them so you can understand them. So let's jump in here. What is ground anyway? The word ground is wildly overused and it has different meanings and It can be a noun, which means a thing, an earth connection, that is the ground. Or it can be just a local reference potential. They talk about ground sometimes in airplanes. They're not dragging a chain, so what they mean is the local reference voltage that everything is based on. It can also be an action where you want to ground something, like you want to short something to the reference potential or to the earth. It can be an adjective to describe a type of a thing. And so you have ground conductor, ground system. And you can use all of three senses of the word at the same time. And I've listened to people having conversations about grounding, and they're both nodding up and down in the right direction. And then I realized they're really talking about completely different things. So you have to be very careful when you say ground, what you mean. The British have taken the word and they use the word earthing. When they mean connect something to a ground rod, they say earthing. And so that helps explain things. Couple of myths about grounding. A lot of times we treat the earth as a kind of a magic 0-volt reference where electrons go into it and bother us no more. And that's not the way it works. The earth is got resistance. It's a distributed surface, so there's inductance, there's all kinds of things. If you dump a lot of current into it at RF or lightning, it will not magically and safely disappear. It will flow and create voltage drops, and we'll get into that later. It's the same thing for a vehicle body. It's not a 0-volt reference. We have to stop, or at least be very careful when we're using the term RF ground. There really ain't no such thing. RF covers a wide range of frequencies. And so trying to create a 0-volt or at least a common voltage across a wide frequency range is a very difficult thing. So you can really only create this reference voltage at RF on a limited number of frequencies, and treating something as the magic RF ground is really a good way to get into trouble. So I try not to use the term. Another is ground loops. Everybody says, oh, you can't have any ground loops. Ground loops are terrible. They cause this, they cause that. Any conductive path around a loop through pieces of equipment or cables or whatever, that's a ground loop. And if you go and you look in the back of even a small ham station, there are literally dozens of ground loops. There are all kinds of these paths. So you can't get rid of them. First of all, they don't really cause all the problems that they get blamed for. And what we have to do, instead of trying to get rid of them, we manage them. So we manage them by reducing the area and through bonding, which is what we're going to talk about in a minute. Another term is single point ground. This really came out of the AC utility field. And what it means is an electrically small contact point so that current does not circulate within a power system. And so you're trying to connect everything together so that it's at the same voltage, which is a bonding thing that we'll talk about. But the idea in the AC was to prevent error currents from circulating in the system. So single point means electrically small. If you're at AC, 60 hertz, the wavelength is about 5 million meters or 50 million meters or whatever it is. 50 million, I think. So something can be the size of a football stadium and still be pretty electrically small. But at 20 meters or 6 meters or whatever, electrically small is drastically smaller. And so you have to be careful about throwing the words single point ground around. Each set of requirements that you encounter, the AC, the lightning, the RF, they use ground differently. You've got to be careful about how you use them. Okay, bonding. We're all bonding here. Yes, that's good. But when you go and look up the bonding definition, all it is a connection intended to keep 2 points together at the same voltage. The key concept for bonding is that everything that's bonded together goes up and down at the same time. It goes up and down together. It's like a floating dock. All the dock and the boats go up and down together when a big wave comes along. And it's the same thing in electrical bonding. You want all of the bonded stuff to go up and down together. That prevents shock hazards from voltage differences if there's a fault. It prevents these destructive voltage differences caused by lightning surge when point A goes to 10,000 volts over point B just for a second. But lightning's really fast and it can create really serious destructive surges of current between the equipment. So by minimizing the voltage differences, you minimize the lightning surge voltage and current. And then RF pickup from your antennas is another problem. And you're really close to your antennas. You're within a wavelength or two. You're in the near field. And what causes RFI is not the voltage, it's the current. It's current getting into something in your station that it's not supposed to. And so if you can limit the voltage, you can limit the current. Current flows in response to a voltage. So by bonding and keeping everything at the same voltage, you minimize voltage differences, so you minimize the current. And for bonding to work, it has to be a low impedance electrically short connection across the frequency range that you're working with. That could be AC, it can be lightning, which is the low AC all the way up to a megahertz or more, and then RF that we use, which is down in the medium frequency range all the way up into the UHF and microwave. So you want it to be short so that it doesn't start acting like an antenna or a transmission line, and it has to be low impedance. That's low X and low R for bonding to work. Now, the different ranges emphasize resistance or inductance. We'll get into that. It also has to be heavy enough to carry the expected current. If you're talking about bonding for lightning protection and you're talking about your antenna system, you have to have big wires, what I call the BAW, big ass wire. That's why they're so big. They have to carry kiloamps. To a circuits guy, the concept of kiloamps is scary to me, and it should be because there's a lot of energy there. And in a lightning strike, even an indirect surge, you can get a lot of current. So the bonding conductors have to be heavy enough to carry it without vaporizing. And it also has to be mechanically sturdy, especially outside. If you're going to bury these things, if you're going to put them in the yard, if you're going to put them around your towers, they're going to suffer from frost heaves. You're going to drive across them. You're going to forget they're there and dig them up with the rototiller. Don't ask me how I know this. And all sorts of other things. That conductor has to be heavy enough so that it will withstand all of that. It's got to jam the rototiller or the shovel and let you know. If you cut it, you may never know that you don't have a ground connection. So it has to be out there. It has to be sturdy. And that's why the building codes specify that kind of thing. Inside your station, what do you use for a bonding conductor? The recommended thing, the standard thing, is some kind of solid metal strap, copper, bronze, brass, whatever. 20 gauge is the standard, about an inch or an inch and a half. And heavy wire also has almost an equivalent surface area to the heavy strap. That number 14, number 12, all that Romex that you refuse to throw away because you're going to use it someday, and it's in that box in your garage. This is the perfect application for it. Get it out, strip out the conductors. These are perfectly good bonding conductors within the station. You can use that flat weave tin braid, the silver stuff, if your equipment moves around or if you need to move the connection around. But protect any kind of a braid from moisture and chemicals. In your car, you'll see this braid used for DC connections, and they don't really care so much. They're worried about resistance, but not so much impedance. If you use this strap in your car, your vehicle, for grounding and bonding, you need to protect it from moisture and chemicals, and they have plastic coated braid. Do not use exposed braid from old coax. You know, you say you got this piece of old coax. I'm going to use this as a grounding strap or whatever. That's fine. But what happens? You've got to take it out of the jacket, peel off the jacket, then you loosen it up so you can take the center conductor out, and you're going to use that as high voltage wire, aren't you? Okay, so once you take that braid out and you loosen it, all those little connections, you know, that you look at it and they're all over, under, that sort of stuff, they start coming apart. Also, the braid is now exposed to oxygen, it's exposed to water. Both of those things are bad. So you got 3 strikes on you: loose connections, corrosion, and water. All of those things are bad. So leave it in the jacket. Just treat it as a BAW, big ass wire. Put some pigtails on each end, put a terminal on each end, waterproof it, and you've got a perfectly good ground conductor. But the minute you take it out of that jacket, which is there to protect and compress it, it starts to degrade right away. So when you do this bonding, when you use these proper conductors and that kind of stuff, short, direct, as much as possible, this works in your favor. It creates a perfectly good grounding system, grounding and bonding system for AC safety, lightning protection, and RF management. Okay, let's talk about AC safety for a minute. I think most of us could run a branch circuit or install light switch or build our own power boxes. Some of the advanced students might be able to do a 2-way light switch. Oh my gosh, okay. But if you're not really sure what you are doing, and I know we're federally licensed ham radio operators and therefore know everything, go out and get a how-to reference. This one on the right side of the screen, the Black & Decker complete guide, is really good. It's under 20 bucks. You can get it at the big box stores or you can get it online. It takes you beyond the branch circuit. It says what to do and what not to do in wiring your house. And it shows you how to wire all these strange things that are out there available for home wiring now. This is a very good book. There's probably a half dozen of these things out there. Get one and follow it. The other book that I recommend is this thing. It's a giant book. It's called the NEC Handbook. Now, the NEC itself is a little book. It's a small book. It's just a book of rules, and it doesn't tell you why or whatever. It's just kind of like a law book. The handbook, on the other hand, the reason it's so big is that it gives you rationale. It has pictures. It explains why you do and do not do certain things. It's available at the library. You can get old copies for like 30, 40 bucks online. They're big, but they're not that expensive. There's only 2 articles that hams are basically interested in mostly. Article 250 is about grounding, and Article 800, and those are chapters, is about antennas. So you can either go copy the appropriate parts or you can download the appropriate parts, however you get it. But the NEC Handbook is a very useful reference. It has special rules for subpanels and outbuildings. And a lot of our stations or auxiliary equipment is on a subpanel in a garage or a shed or a shack. What do you know? Someplace out in the yard. There are very special rules for wiring and grounding these things so you don't create shock hazards. And people are electrocuted every year because their outbuilding or their garage isn't grounded properly. And so they're standing there barefoot on the concrete slab. Concrete is amazingly conductive. Standing there barefoot and they touch something and there they go. So follow the rules for subpanels and outbuilding. Can't stress that enough. And then at the end of it, if you do anything complicated, why don't you hire a pro electrician, one of your local licensed guys, to come over and take a look at your work. Pay them for an hour. It's not that expensive. Inspect it. Maybe they'll save you a lot of trouble. You know, and say, you know, you really should do it that way, or here's how you should do it, or this is not up to code. Local code is the law, and it's not there to make your life miserable, although sometimes it does. It's there to keep you from burning your building down. The NEC is developed by the National Fire Protection Association, and that tells you a lot right there. Your local code is the law if you want to get paid by your insurance company in case there's a problem, or if you want to get insurance twice, you got to have some kind of confidence that your electricity is handled properly. So follow the code and know what you're doing, or hire somebody that does. Let's talk about lightning protection. Excuse me. Okay, lightning comes from up there, way up there, 30, 40, 50,000 feet. So by the time it gets to the ground, it's pretty well decided where it's going to go. You can't steer lightning. You know, you can't say, oh, I'm going to make sure it goes over there. It'll go where it wants. But you can help Mr. Lightning make good decisions, okay, by the way that you build your system and install it. What does lightning want? It wants heavy, direct paths to the ground so that it can dissipate whatever charge imbalance there is, positive to negative, whatever. The idea is to equalize the charge imbalance. So the charge has to get into or come from the ground, and there's a lot of it. So give it heavy, direct paths wherever possible. And for lightning, because it's an AC kind of event, inductance is more important than resistance. Down at AC, we care more about resistance. We want to make sure the safety and the ground conductors can handle any kind of a fault current, so the protective devices will open up and remove power. For lightning, which is an AC thing, we want low inductance. Even a straight piece of wire has inductance. A 1 foot piece of number 12 solid wire has about 330 nanohenries of inductance. And if you hit it with a kiloamp per microsecond pulse, it's going to develop 712 volts approximately from one end to the other, just from the inductance, not the resistance. So inductance is very important. You want low inductance paths in your lightning protection system. And all of those paths, as much as possible, should be outside, out there somewhere, outside your residence or the building. Don't make it easy for lightning to go through your station, through your house on the way to the earth. Don't put grounding conductors in the crawl space, in the basement, in the attic, in the walls, anything like that. Make sure it's outside. It's inconvenient sometimes, but you do not want a lightning path through the house or the station on the way to the earth. Let's talk about single point ground panels. Now here's a place where single point is really accurate. The idea for a single point ground panel, usually this is an entry panel for the ham station, is for it to bond all of the entry paths, all of the grounds together at one spot, very, very close together. Most entry panels are a couple feet by 18 inches or something like that. That's pretty short at most of the ham frequencies that we care about. And then that is connected to your perimeter ground. We're going to talk about perimeter grounds in a minute, but that's the grounding system outside the house that gives those heavy direct paths into the earth. So your single point ground panel bonds all of the grounds together, connects them to the ground system outside. And all of your protectors, your lightning arresters, your data line, your phone line, your AC service, your protectors are mounted on this panel, even though it's somewhat inconvenient. They are mounted on this panel so that they fire at the same time. And when you fire at the same time, that minimizes the voltage difference. You don't want one protector way over here and another protector way over there, because what that creates is big transient voltages between different parts of your system. And those can be multiple kilovolts. And it doesn't take very long for a multiple kilovolt electrical pulse to generate a lot of destructive current. It just takes microseconds. So you want all of your protectors together so that they fire at the same time. And that's not just your lightning protectors for your coax. It's all these other different kinds of connectors or protectors. Sorry about that. Okay, so here's a typical single point ground panel, sort of a schematic view, where you've got a metal panel. It doesn't have to be copper. It can be aluminum. It can even be galvanized steel, whatever. It's a big common metal panel. And everything that protects your system is mounted on this panel. That includes an AC power protector. Yep, it's mounted on this panel too. So there's your classic, I'll wave my cursor around here. Here's the classic lightning protectors. Here are protectors that go to a rotator or some kind of control line, your data or phone lines, all these service boxes. They have a rule that they have to be connected to a ground system. So they'll either put in their own ground rod or they can connect to your ground system, which is what you want. If you can make everything come into your house at the same point, usually close to the AC service entry, that's the best thing. Although it seems to be federal law that the ham station is all the way on one side of the house and the AC is on the other. But increasingly, more and more, all of these systems come to the house at the same point. And it's so that they can be protected with this common ground system. Now, you've got one group of cables that are protected. They're on the uphill side of the protectors. And then you've got another group of cables and wires that are unprotected. Okay, so you want to keep your unprotected stuff away from the protected stuff. And I know it looks really nice if you bundle it all together and you put the tie wraps on it and you put it in the conduit together and all that, and it looks good. But what happens really in that case is the lightning comes along and says, oh, I'm just going to jump straight from this cable over to this unprotected cable. I'm just going to go around that protector stuff. And so what you do is you defeat your protection by bundling all the cables together. So keep the protected stuff on one side and the unprotected stuff on the other. Here's an example of a single point ground panel. This is from K4RO, and Kirk lives on a hilltop west of Nashville, lots of thunderstorms. Every time a thunderstorm came through, he was losing some piece of equipment in his antenna system, blow something up, a filter, a switch, whatever. And so he finally said, okay, I'm doing the single point ground panel thing. And he's got a big panel of aluminum here. This is in his garage, and his shack is directly above this panel. Then he put everything on the switching output side of his antenna system on this panel. Here is his big ass wire, BAW, goes outside. I think it's number 6, like we all use, and that goes outside to his ground system. Okay, since he has installed this stuff, he has lost exactly 0 pieces of equipment. So this has been several years, and it makes him a very happy camper not to have to worry about things when he hears thunder. Here is an example of a single point ground panel at a tower base. I have a station in rural Missouri. It has 3 60-foot towers, and it's kind of on a high spot. It's not on a mountaintop, but when I bought the property, I walked around it and I saw a lot of burned trees. And so I call it the Crawford County Cumulonimbus Discharge Facility. And I know that it gets hit on a regular basis. So each one of the tower bases has this single point panel. You can see that there's a coax switch. This is a MFJ or Ameritron RCS4L, which means it has the lightning protection gas discharge tubes in it. You can see the main hard line coming in and then antenna wires, cables coming out of here. Each one of these is in about an 18 by 18 by 10 fiberglass electrical box I bought surplus online someplace. I created my panel, piece of aluminum roof flashing right here. It's attached to the box. Here's my BAW ground wire right here. It's connected to the coax switch, and it goes to a ground system outside. And now I'm going to save you some serious money. You can see these little guys right here. These are gas discharge tubes. You can buy them from Mauser or whoever in quantity. They're the smallest ones that are made. They're 75 volts. And what I'm going to save you money on here is this is the rotator control cable right here. It's not the fancy, expensive 2 big conductors, 6 little conductor, multi-conductor cable that we all grew up with. This is 10 conductor irrigation system control wiring. It's number 18, 10 conductors. 2 of the conductors are paired up for what we call pin 1 and pin 2, the solenoid circuit of a standard rotator connector. This is sheathed in bury ready PVC. It's made to be buried in the ground. And it's way cheaper than the fancy rotator cable. Save your rotator cable for rotator loops, stuff in the shack, things like that. And so I just run the cable in. I put a gas discharge tube on each line, and then here's the cable that goes out to the tower. Okay, let's jump back a little bit to this perimeter ground idea. The idea, and this is not just a suggestion, if you read the NEC, all earth connections shall, there's no wiggle room, shall be bonded together. It's required, and you do not want multiple external connections that are not bonded together. Well, why? Okay, so you've got, here's your electrical panel, here's your phone service, here's your TV, cable, satellite, whatever. You've got an antenna on the house maybe, and everybody's got their own ground rod, just like you're supposed to, right? Not quite. Okay, you have to bond those together. If you do not bond those things together, then what are they connected together with? They're connected with dirt. Okay, what is the resistance of dirt? It's kind of high. If you measured the resistance between 2 ground rods, you'll get 10 ohms, 20 ohms, 50 ohms. And that's not good, because if you have lightning that strikes anywhere in the vicinity, whether it hits your house or your power line or just nearby, you can get thousands of amps flowing through the ground. And thousands of amps times 10 ohms is tens of thousands of volts. And so you can have, even though they're grounded, you can have tens of thousands of volts between these different systems in your house. And that's when you hear stories like, I was minding my own business, there was a thunderstorm, I was sitting in the living room, there was a big flash outside, and suddenly a big green arc jumped from my computer to my home entertainment system, and now nothing works anymore. Okay, well, it's because the grounds were not tied together. So outside, all these ground rods shall be bonded together with a heavy conductor. Number 6 is about the smallest that's allowed. Some codes require number 4, number 2, whatever. Get your ground rods out, get a ground rod pounder, or hire some guy to go out and pound them in for you, and put in a ground rod every 2 times the length of the ground rod. You got 8-foot ground rod, then every 16 feet. Outside the house, connect them all together as much as you can. You may not be able to go all the way around the house, but do as much as you can. That's sort of a protective ring. And that's called a perimeter ground. Okay, the other thing we talked about was don't create paths for lightning through your station. So here's a typical example. All right, here's the tower outside, and the lightning comes and either it hits the tower or it hits nearby or something, and you get a big lightning surge. Here comes the current surge down the tower, and it says, oh, here comes some feed lines. I'm going to follow them. Here's my nice entry panel. It's connected to a ground rod, so some of the current's going to go there, but the lightning's going to go like any other current. It's going to flow in every path available to it. Well, here's a nice path. You've got all these heavy cables that go into your station, and your station is plugged into a branch circuit, and the branch circuit has a ground in it, and that goes over to your AC service entry, and there's a ground rod there. So you've given lightning a tremendous path right through your station, through your AC service to the ground. And that can cause a lot of damage. So don't do that. What you do instead is you protect your AC path. You put all your protectors on this single point ground panel, and you have a very nice perimeter ground system outside. Multiple ground rods. If your tower is close to the house, say 50 feet or less, you want to bond that up there too. And so here comes the lightning surge. This time it hit the power lines, which is quite common. comes in, says, oh, look, I've got this really nice perimeter ground system, a lot of heavy direct paths to the earth. And well, there's also an unprotected AC circuit. Yeah, well, I'm going to flow over here, but here's my AC power protector. So instead of flowing into your radios, that surge goes through the protector and into the ground system. So the idea is heavy direct paths outside. And if you want to add extra radials to your ground system in your yard, that's just dandy. But don't give lightning its main path to go through your station on the way to the earth. Here's a typical lattice tower, Roan 25. We've all seen this picture in the handbook multiple times. You're looking down on it. You've got a ground wire, a ground rod for each one of the tower legs, and they're connected together with a ground ring. Okay, as long as you got the guy with the backhoe out there, have him drill another 30 feet, just scrape another 30 feet of trench. It doesn't have to be 6 feet, just 18 inches will do, and put in a heavy radial with a couple of ground rods in it. And that will really, really help ground your tower. Also, bond your feed lines to the tower every 50 feet. Remember that number 12 wire that had 700 volts across it from a lightning strike? Your tower in a lightning strike can develop 50,000 to 100,000 volts between the top and the bottom just from the lightning and the inductance of the tower. And that will blow your coax up. It will damage it. It'll do all kinds of nasty things. So bond your feed lines to your tower using a bonding bracket or kit every 50 feet. It's a pain in the neck. You have to do extra weatherproofing, but it's worth it since you don't have to replace cables all the time. If you've got an insulated base tower, put a little spark gap down at the bottom. It can be as simple as a spark plug or just a couple of wires that cross and make them about a millimeter or two so that lightning will jump across them instead of going into your station. Okay, let's talk about RF in the station. First thing you got to realize is everything in the station is an antenna. Absolutely everything. Yeah, your antenna's out in the backyard, but you're in the near field. What's the wavelength of 40 meters? Trick question, 40 meters, that's about 120 feet. If your 40-meter antenna is less than, say, about 200 feet from your station, you're in the near field of the antenna. And even if you're not right in the near field, you're really close. So you're going to pick up a lot of RF. Every piece of wire, and you are conductive, so you're going to pick it up too, is acting as an antenna. So you're going to have RF in the station. Again, forget about an all-band RF ground. That doesn't exist. There's no 0 volt anything. What you want is concentrate on bonding. So you have 0 volt difference. You don't want the differences. Whatever that voltage is, you want it to be the same everywhere in the station. You do that with bonding with electrically short conductors. That keeps it all at the same voltage so you don't have current flowing because of RF voltage differences. If you've got an amplifier, not only do you meet your neighbors, but you also have high RF field strength, which requires extra attention to bonding. And it really helps a lot if you create a common reference plane, which is basically a fancy word for a metal sheet, under your equipment, or some kind of grounding bus along the equipment. You've seen this picture in the handbook for many years, where we have a bonding bus, an RF bonding bus. Usually it's a piece of 1/2-inch copper pipe. You can also use aluminum angle, anything that's good and conductive, and you put ground clamps on the pipe. You can either use the little acorn ground clamps, or you can put sheet metal screws in the pipe. Do not use the regular stainless steel hose clamps. They're not made for this, and they loosen up. They're made for metal to soft, squishy stuff, connections, hoses. So use sheet metal screws or ground clamps, or what I've started using is these little grounding bars. They're available in 7, 9, 17, 23, all these different positions. They go in AC service panels, and they are the neutral or ground bus. They're not expensive. They're made for this service. You can bolt them right to the reference plane, and that works really well. So the idea is to reduce RFI from this common mode current that is picked up and conducted on all the cables. If you don't have voltage differences, you won't have current flow. And this also reduces sensitivity to how your station is assembled. So you don't get into a situation, well, to operate 15 meters, I have to sit over here and I can't put my feet on the floor and I have to hold one thing or I get an RF burn. No, this makes it all one electrical thing. That's what bonding does for you. We talked about ground loops before. What causes a ground loop to pick up and a voltage and cause a current is the area. The bigger the area of the loop, the more voltage it's going to pick up. So you want to minimize cable length and you want to minimize loop area, those two things. Use short or coiled cables. It seems like you can't buy cable, data cable or RF or whatever, that's less than about 3 feet or 18 inches. But use the shortest cable you can get. If you've got a long cable and you don't want to just have it laying around all over the place, coil it up in a figure-8 pattern, and that minimizes the inductance. And then you lay everything on the reference plane or connect it right along that RF bonding bus. You minimize the area, you minimize the amount of RF you're going to pick up. Always use shielded cables for anything, audio, RF certainly, all control stuff. About the only thing you can get away with using non-shielded cable for is power. And all of your grounding conductors have to be short straps or wires. Here's an example. This is at my station. This shiny thing here, it's roof flashing. It's a piece of 12-inch roof flashing that I took my unfortunate Costco banquet table and I just used sheet metal screws to attach it at various points along the table. All of the cables lay on that. There's a bonding bus in the back and everything's connected to that. And aside from a very few problems, and I'm running 2 stations with full power outputs, I just don't have any RFI or RF induced problems. Ground system review. A single ground system, short, heavy, direct connections satisfies all of the requirements for these 3 things. You want to bond all of your grounds. You don't want your AC safety ground separate from your lightning ground, separate from your RF ground. Don't do it. They all have to be connected together. Keep your protectors together so they all fire at the same time and minimize voltage difference, and create your perimeter ground outside to keep your lightning current outside the building. Let's jump over to mobile stations. The RF issues can often be really intense because you're in the antenna. Yeah, the car is part of the antenna system. You're in the car. Your radio's in the car. You're part of it. Okay, there are also some special power wiring considerations. Bonding in today's vehicles is a lot harder than the old days. And what about mounting the equipment and the antennas? So you want to consider where your fuses are, ampacity, which means how much current the wires can carry, and the voltage drop when you're pulling the full 12-volt current through these conductors. You always want to fuse both leads and use heavy wire. The negative lead must be fused as well. So if there's a fault in the system, the fault current, which can be substantial, doesn't find its way back through your radio and through the negative lead to the battery. That's basically a fire. It will burn up your radio for sure. It can really damage your car. Remember that 12-volt radios aren't really 12 volt. They want a minimum of 11. What they really want is 13.8, which is the charging voltage of a lead acid based automotive battery system. They're designed for 13.8. They can go up to 15. Give them a lot of voltage and they'll be happy. If you start getting down below 11 volts, you get some really strange behavior from your mobiles. So you got to take that into account, especially when you're dealing with voltage drops. You want to use heavy wire and you want to use connectors that do not have a lot of voltage drop. Okay, And then we got to talk about where do you connect your power return and battery monitoring systems. And then there's these weird DC booster things. Okay, power return. If you've got one of these dudes on the negative terminal of your battery, then you have what's called a battery monitoring system. This is particularly common in newer cars that have what's called engine idle shutdown. If you pull up the stoplight, the engine stops. It's an emissions management thing. But then when you get ready to start up again, it cranks over the engine and away you go. Okay, so to keep the battery fresh, because it gets used a lot in these systems, the battery monitoring system counts every electron that goes back and forth out of the battery. That's what this little thing is here. And so your computer will sense how much current's gone in and out and make sure the battery is fully charged. Well, if you connect your negative from your radio here, what you do is you bypass that system. So the computer doesn't know about your radio current, and eventually you'll discharge the battery because you fooled the computer into thinking less current was taken out than really it was. So what you do is you got to go dig down into the bowels of the earth and find this big heavy chassis ground point where the starter motor reconnects, and that's where you connect your fuse power return system from your radio. If you want to minimize pickup, twist your power cables together, and that will help minimize RF pickup. But home run wiring is what it's called, and you want to connect down here. So connect there and not to the negative power terminal on your battery. Then there's these boosters, so that your car, all of your electronics doesn't go off and back on every time you come to a stoplight in these cars. They use DC to DC boosters that keep the voltage to the system exactly 13 point whatever. So they even out that voltage. Okay, do not use those boosters for ham gear. They're not rated for it. They do not want to provide an extra 7, 10, 20, 25 amps for your transceiver. Get your own doggone booster, okay? Wire it in just like the other ones, same chassis ground point, home run radio, and run your gear off a DC to DC booster. It'll run better. Everybody will be happy. Bonding in mobile stations can be a real problem because the body components of the car aren't always even metal, and so they're not always well bonded. You can't just drill a hole someplace and say, it's metal, so it must be ground system of the vehicle. Don't. You've got to be very careful about where you connect your ground returns. Don't use the subsystem ground points. I mean, for the computer system or some kind of controller, what happens is you inject all that radio current into that ground point, and the voltage can go up and down a little bit. That can confuse or upset your subsystem operation, and it looks like you've got RFI. You don't have RFI, you have DCI. You have DC injection into that ground point, causing the voltage to go up and down when the subsystem doesn't expect it. So don't bond to these points. Go all the way back to the power source. And when you bond to the body, you create all these new strange return paths for DC and RF paths. So it can be very difficult. You want to bond to the body for antennas, but not your DC stuff. Anytime you make a contact out in your vehicle, use these anti-corrosion compounds that are designed for vehicle use, and they protect the connection, and that keeps them from corroding over time. Sometimes you put in a new system, it works just great. The months go by, particularly the winter months, and there's a lot of thermal cycling, there's salt, there's all this other stuff, and strange things start to happen. Use these connector protection compounds when you're wiring in your vehicle. Another thing that you can do is mount your equipment in these standalone racks, these little mini racks, and then everything's bonded right inside this rack. You don't have to worry about using the car, and then you can make one connection to the vehicle if you want to. Truck toolboxes, carry case stations, all this kind of stuff. The only problem is if you can take it in and out of the car easily, well, so can somebody else. So you have to worry about the security of your station equipment if it's in one of these standalone systems. But it's all nicely bonded together, and it generally minimizes RF problems. Another thing is You don't have to bond this stuff to the vehicle. These radios, particularly mobile radios, are designed to work completely independently of being connected to the vehicle, except for power. I mean, we've all done it. We go to the Hamfest, we buy this nice mobile transceiver, and then we shove it down between our seat and the transmission hump, and we go, oh, we'll fix that later. Well, it's a temporary thing, and you know what temporary means in ham radio? It means until I die. So it's going to be there in your vehicle forever. There's really no need to bond that to the vehicle. It works just fine. Control heads are the same way. Unless the manufacturer of the radio tells you to bond the control head to the vehicle, don't do it, because you're creating some other kind of weird path that was not in the design, and you can cause problems. Mechanical security, please don't let your radios flop around in there. Tie them together. Even the one that's down in between your seat and the transmission hump, why don't you put it under the seat? Take the control head out or something, but tie that sucker down so that when you are in an accident or anything, you don't have this multiple pound metal object flapping around in your passenger compartment. And there are airbags everywhere now. Side bags, top bags, front bags, and anything you place on front of one of those panels, if there's an accident and those things fire, whatever's on front of that panel is going to come at you at about 100 miles an hour. So you don't want a control head or a microphone coming at you at that kind of velocity. So find out where those airbags are and don't mount anything there. You can use the channels under the door trim and stuff like that. There are secret passages in your vehicle. Use them, because that's what the manufacturers do. They shield your cables from direct RF pickup. It protects them mechanically. Get a service manual, read through it in the body sections like a Chilton's or something, and you can find out where these things are. Also, there's a lot of hidden wiring that you don't know about. So when you're drilling holes, only drill a little ways so you don't drill into a control cable, or worse, 12-volt power. Service bulletins and repair manuals are good stuff. When you're mounting an antenna, bond the antenna to the body right at the antenna. Well, here's my helper. The through panel NMO mounts are probably the best. Motorola did a lot of work with those. They don't really work at HF, but the NMO is your best above the HF. Lip mounts that go on to hatchbacks and trunks, they need an additional body bond. They've got these little set screws and stuff, but put in some extra screws and a big protected bonding conductor to the nearest tie point. The paints and coatings on vehicles are really good today, and they will, you think you're biting through them, you may not be. Mag mounts, they'll keep your antenna on the car, but at HF, you only get about 100 picofarads per magnet. So you don't rely on the magnets as you're coupling to the body. If you do, what you're really doing is you're saying, okay, I'm going to make the coax shield part of the antenna. So you get a lot of common mode current that conducts it right back into the passenger compartment where the radio is, and you get RF problems. So run a separate bonding wire from wherever the mag mount is over to the nearest possible point, maybe in the door or window frame or something in the trunk or somewhere on the body. So you've got a good solid connection. And when you're decoupling stuff at the antenna and the radio, ferrite cores type 31 at HF are your friends. See Jim K9YC's tutorial. If you're buying a new car, talk about an upfit package, which is, hey, take this vehicle and I want to put two-way radio stuff in it. They have packages for almost all of these cars. If your salesman doesn't know about it, ask to talk to the fleet sales department of the dealership. They will know all about it because they want to sell cars to public service and commercial vehicles, and those often have lots and lots of radios. And the manufacturers have made it easy for this to happen. Your service department will help you. Your manufacturer service bulletins will help you. And, you know, you can always just take your radio to a car audio or two-way shop and say, here, put this in my car. And they'll do it. They have all the little parts and the wires and all that kind of stuff. Plus, they have knee pads and their backs don't hurt, and they have nice warm shops to work in. it's money in the bank for you, and it's done professionally. So that kind of wraps it up. I've got a couple of minutes here for questions. Happy to answer them. Like I said, email me if you want a copy of the PDF slides. So do we have any questions? I put you all to sleep. I baffled you.
I got
Okay.
a question.
Go for it.
I don't know if I'm on the camera. Anyway, awesome. Love your book. Okay, so I have on my station, I have a metal pipe behind where the radios bond to it.
Yeah.
Then down in the garage, which is right below my operating desk, I have that's really where my single point connection panel is, where my arresters are
Yep.
located. What do I bond that copper pipe down to the single point?
You absolutely do bond to that. If we go back to that K4RO thing where he's got the single point panel in his garage underneath his station. You go up in
Yeah.
his station, he's got a big bonding bus up there. He's got, it's a 2 radio full power station, so he's got a lot of RF up there. It's all bonded together, and then a big bonding conductor goes down to that single point ground panel. So you definitely want to bond it. I would use just a piece of heavy strap. Go get some copper roof flashing or something like that, and just run it down below the floor into your garage, and that'll do the trick.
Thank you.
And I'll touch on second floor stations. I'm sitting in a second floor station right here. Everything is bonded together, but you're so far above the ground that a connection to an outside ground rod doesn't really make a lot of sense for lightning protection. There's too much inductance. So the idea is to bond everything, just treat it as if you were in a plane. Everything gets bonded together in your station. Run all of your cables down to ground level. That's where you put protectors right there at a ground system, and then run the protected cables back up the side of the house to the station where they come in. That's my recommendation. It's not always possible, but you do what you can. Any other questions?
Okay, I have one more.
Yeah.
My tower is 75 feet away. I have buried my feed lines in conduit. I have grounding at the tower. Do I need to bond the tower to the house? Bonded ground rods?
It will not hurt, okay, to do that. But once you get up beyond, there's no definitive number here, but once you get beyond about 50 feet, the inductance of that conductor is so high that it doesn't really buy you very much to bond. Now, at AC and very low frequencies, it doesn't hurt anything, and so it helps tie everything together. NEC allows you to use the outside conductor of feed lines, i.e. the shield of coax, as the grounding conductor. So you already have a pretty good grounding conductor with the shields of your lines that goes to your entry panel. But if you want to run an extra ground conductor, I would say a bare one in the ground next to that conduit and goes to your home system. That gives you a lot more ground surface, so that's good, and it doesn't hurt anything. So, but it's not required.
Thank you.
There we go. I see Rob. Hi, Rob. Rob Sherwood. Okay, so that is my cue. That's that big hook over at the right side of the stage coming out. Okay, so gentlemen, thank you very much for your attention. I enjoyed talking to you, and email me if you want the slides, 73.
Thank you, Ward 73.
Right on time. There we go. Rob, have a great presentation. Always look forward to your stuff.
So you're still sharing your screen, Ward?
Yeah, I'm going to stop it right now. There we go.
All right, very good. Let me see if I can share here. Okay, we're full screen. Let me take the video and put it on another screen here for me. So, home. Okay, good morning to everyone. I'm in Colorado, a couple hours ahead of you or earlier than you are. So I'm going to be talking about transceivers and maybe how you pick one and whether you need one or not. So one thing I do want to say, focus on your antenna. If you've got an option, which you may or may not, the antenna is probably the most important thing. So let's look at the big picture and then talk about some rigs that you may want to consider buying, and hopefully you got some options there at the Hamfest. So are you considering a new HF rig? So it's a subjective decision. So you're going to say, well, what's going to work for me? And I would say it's a fairly complex decision. And what do you need on the air for your typical operating day? If you mostly operate single sideband and FT8, you really don't need a $5,000 rig or a $4,000 rig. Maybe you want one, but you don't really need that. But then if you do have an option to say spend the first $500 or something, consider your antenna, but it may be limited by an HOA, or maybe the family says, well, I want it to be invisible. What makes it difficult? So I just have to make decisions on what makes sense for you. So what's changed in 10 years? Well, there's lots of lab numbers from the league and myself. The receivers are phenomenal, but the interface, the user interface, how you interface to the radio with the computer or LCD screen or whatever, is all over the map. And I consider every radio today an SDR. It's a term that used to sort of mean, well, I run it with the computer, but now every radio's got computer in it, software in it. So the term SDR really doesn't tell you anything anymore other than that we have a lot of flexibility. So how do you interface with the radio? Is it a standalone box? Does it need a computer? Does it have a small LCD screen in comparison to what your computer has? Or do you have a bunch of large screen LCD screens, which a lot of the radios will support? That's totally up to you. Does your radio mostly have knobs and buttons, or is everything touchscreen and a mouse? So this is just so different, and it's just what works for you. And really a band scope, almost everything in the last 7 years has a band scope, and you may or may not need that. If you're just rag chewing, you probably don't care. If you're a contester running what we call search and pounce like I do, very important. So how old is your current rig? If it's more than 10 years, it's a new experience. So we've got several general types of radios today. A superhet, of course, that's been around forever. A hybrid superhet, which means it had a direct sampling scope. And then we've got direct sampling radios, and we'll look at those in detail. And then a term that is fairly new, probably won't catch on, but Dr. Ulrich Roda, he says IF direct sampling, and I'll explain that. So I would say the typical example of a hybrid would be the TS890S, and I had one of those for several years, very nice radio. And this IF direct sampling is what all the brand new Yaesus that have come out in the last 5 years. So they're kind of off in their own little niche. Actually, the only major brand right now that doesn't have a direct sampling of some type is Kenwood, but everyone else has it in some way or other. So does the architecture matter? In other words, what's inside the box? Most of the time it does not. A superhet has a roofing filter and an IF of anywhere from 5 megahertz to 70 megahertz. And you don't really care where the frequency is, but that's what follows the first conversion. And then the hybrid superhet has a direct sampling band scope, but the radio is a superhet. And this term that I say is new, IF direct sampling, we still have roofing filters, but then once you've hit the IF, there's where the audio to digital converter or analog to digital converter occurs at the IF. So pure direct sampling only, do not have roofing filters by definition. Probably doesn't matter most of the time unless you've got local signals that are like 60/9, or of course field day or something like that. So what architectures are dominant today? So let's just look at the superhet. We're not talking about something from the 60s, but a TS590 or an ICOM 7100. And the hybrid superhet, Well, I think really the only one that's exactly that definition today would be the TS890S. In other words, super het direct sampling scope. And this new term, IF direct sampling, would apply to all the new Yaesu products, the 101D, the 101MP, or the FTDX10. And then direct sampling, and I'll show you 7 of those in a moment, but the K4D, for an example, the 7610, and all the Flex 6000 series. So those are the pure direct sampling. So any type of direct sampling has to have this ADC chip, the analog to digital converter, in the receive path. Only the IF direct sampling have roofing filters, which will be an advantage in really difficult environments. But all but the super hets have an ADC someplace in the radio. So what limits reception? Well, the receivers are so phenomenal today, but if the interference is in your passband, you can't get rid of that. And that could be key clicks, which unfortunately are more common than you'd like, or splatter on sideband. If you've got a strong signal 3 to 5 kilohertz away from you, and that splatters in your passband, this perfect radio can't get rid of it. Now, if you've got signals that are line of sight, transmit composite noise can be an issue. And in that case, the signals are probably S9 plus, 50 or 60 over. And field day would probably be the worst case because we've got all these rigs within a diameter of 1,000 feet. So the choice of the radio for field day, for instance, is very important, that you don't want one that puts out a lot of noise. So besides field day, well, hams that do multi-multi or multi-2 would be prime cases where a roofing filter is an asset. So the challenge cleans transmitters. Well, since we all share the bands, we would hope that the OEMs, the original equipment manufacturers, would improve the transmitters. This is something that hasn't changed much in 30 or 40 years. Because we're all using our receiver and realizing whether it's doing a good job or not, the improvements in receive performance in the last 10 or more years is tremendous. But not much has changed in the way of the transmitters. Now, does the typical ham care if his signal has bad key clicks or splatters or has transmit composite noise? He should, but you say, well, I don't care, I'm not hearing it. But everybody else out there, you have to deal with what they're transmitting. So we would hope that all of us would get better over time as the OEMs improve things. So what's new when comparing rigs for my website and my QTH, where I am right now out in the country? So for the last 17 years, I've added on-air observations to my long-form reports to augment what's on the lab, on the website, or in my reports. So let's take a couple of examples here. So this is one of my 3 operating positions. I have more than one because I'm often evaluating a new radio. For instance, the FTDX10 and the FT710. I ran those for 3 months at operating position 1 and 2, so I could really get a handle on it. And I ran contests, brag chewing, you name it. Here's my antenna farm. So I really do emphasize, if you can improve your antenna, do that first. So let's look at some contesting screenshots. You can learn how to set up your radio the best way possible. I want to really emphasize that a preamp and attenuator is the tool. Very important to know when to use it, but you don't just turn them on and leave it on all the time. So the default is not the preamp on and it's not the attenuator on. So let's look at some 10 meter and 160 meter examples. So this was December 2018. I was running a TS890S and it was the ARRL 10 meter in Saturday afternoon. So what do we see on this screen capture? Well, on the upper right-hand corner, I've got the preamp on. It's 10 meters. Now, this was pretty much at the bottom of the sunspot cycle. So there were 20 stations or more in a 10 kilohertz span there on the band scope and the waterfall. But their signals are fairly weak. If you look in the lower right-hand corner, I have the audio peak filter, and that can be used either just to reduce noise, which is the way I do it. I don't run it really sharp, but it reduces noise. And if you're in a contest for, 10 or 20 hours, noise is really tiring. So I try to reduce noise as much as practical. Here was the week before, the same year, 2018, for the 160 meter CW contest. Again, looking at just 10 kilohertz there on the band scope, more than 30 stations, and look how much stronger they are than the 10 meter example. So lots of things are in this picture that can be useful. So if you look over on the left, instead of the preamp on like I had on the Kenwood, on 10 meters, this is the attenuator is set at 12 dB. I mean, all the rigs today are certainly work on 10 meters and now 6 meters, so they have to be sensitive enough to work on the upper HF bands, but they're way too sensitive on the low bands. So there's no point in having band noise reading S7 on the S meter, for instance. So in this case, I was running 12 dB. In the upper middle, you can see the audio peak filter was on, just like I did with the Kenwood. And we can look at the signals, and there was more captured there than I really expected. This was just basically to show, look how many signals are in a 10 kilohertz swath. But look what we see on the left, where it says key clicks 5x. The signal, as you can see on the band scope, is quite wide, and on the waterfall, it's quite wide. But then we look over at the right where it says clean. That signal's 3 dB weaker, totally insignificant. But look how narrow that signal is on the band scope and really obvious on the waterfall. It's just nice key click free signal. And then let's look back at the one on the left. If you can see there on the lower down on that key click pattern from that guy's signal, which is bad, there's a little tiny signal trying to peek through the guy's key click, so it'd be harder to copy that guy. And you can see that little signal on the band scope, and you can see the little signal in the waterfall deading away. So we really don't want to have a signal that's 5 times as wide as the other guys. Now, one thing I want to comment on this attenuation, which probably a lot of people don't do. Now, I find that if I'm just on the air in a rag sheet, it probably doesn't make any difference. But if I'm on the air for hours and hours in a contest or trying to work a DXpedition, I like to reduce noise fatigue. So one year, I had, in most of my contest run evaluations are in the fall to early spring, I didn't have anything new like the Kenwoods that, like the Yaesus that I've been using for about a year and a half. Well, I had a 7300 and a TS990, and the vast difference in size and price and the size of the screen, for instance. Well, to compare the two, while you can use an RF gain, I like to have a known attenuation on 160 meters, so I just know exactly what I'm doing. So the ICOM 7300 only has one 20 dB attenuator. So then to make it fair, I ran the TS990S with its 18 dB attenuator for the whole contest. And this was, I'd never done that to that extent. I always just ran 12, but actually I liked it a lot because as I was doing a search and pounce operation, I'd be working a station, tune into the next station, and in between all those signals, there's band noise. But because I had so much attenuation, the band noise was almost out of the picture. Now, I did have to turn the AF gain, the audio gain, up every once in a while, like maybe 2 or 3% of the time, because look at all those signals. They're way above the AGC threshold. But so that was the trade-off, a little more requirement to turn the audio up, but the noise was so much reduced that it was very low fatigue, and I just loved doing that. That was the first time I'd carried it to that extent. Okay, so we looked at key clicks, and they can be wide and annoying. The sideband has the same problem. So here's a couple of screen captures that were done in Boulder, Colorado, of a 75 meter QSO that I join on the weekends. And this is to show the difference between a typical signal today. As I mentioned, the transmitters really haven't improved unless they have something special. So we see the station that's there in the waterfall that's narrow was running an Apache 200D with Pure Signal, which is a software solution to reduce distortion products, in other words, splatter. So today, what are our options? Well, Class A used to be offered by Yaesu, but the current 101 MP, for instance, does not have that. So Class A is gone. ICOM now is offered since Thanksgiving, unofficially, because it's really only officially available in Japan. They have digital pre-distortion, so that is a big improvement. Well, Flex has been talking about pre-distortion for 10 years, and the K4 Elecraft company has been talking about it for about 5. But so far, we've got Apache with Pure Signal for 10 years, and now ICOM is now just has an option there too. So they'll look at the bottom of this waterfall, and there's my Kenwood TS890S, and you can see I have splatter sidebands because we're strong. We're looking at like the signal is about 30/9. But then look above it where the gentleman with the Pure Signal pre-distortion, his signal is almost just a pure rectangle. You can even see little RFI, probably from a switching power supply in some neighbor who was receiving this signal. On the right-hand edge, you can see that wobbly little signal. You can't even hardly see it when I was talking. So that's unfortunate. So here's what's changed. Now, in this case, I'm using an ICOM with this new digital pre-distortion. And that's me in the upper portion of the waterfall. And you can see there's very little splatter. And then down below, again, another station in Colorado, 30/9, both of us were. And that happened to be a Flex 6700 driving a Power Genius. And there you can see the splatter sideband. So this is what's possible today, to have cleaner signals with what we call pre-distortion. It's like inverse distortion. You correct for the distortion in the transmitter and or the exciter and or the amplifier. And there's one way to look at it, just with us sampling a signal for like 15 seconds. This happened to be, I was transmitting on one ICOM, receiving on another with an antenna 800 feet away. And you can see most of the signal is pretty much straight up and down. So is it a time for a new rig in your shack? So there's lots of great choices if you operate contests or DX pileups. In general, I'd say if you rag chew and operate FT8, what you have now may be just fine. You're not stressing your radio. But then the more current radios, they have a built-in sound card. So making WSJT or the other digital modes operator so much easier than it was 10 or 15 years ago. Here's some information from my website. If you've ever been there, it lists, well, there's over 150 receivers and transceivers on the website with laboratory data. Now, this is not the first 1 through 25 because there's duplicates. For instance, the K3 came out in 2008 or maybe really late 2007. The K3S came out. The direct sampling radios have more variability from sample to sample, not because of the box, but because of the individual ADC chip, the analog to digital converter chip. So there's just a little more difference. So there'll be a second sample for a lot of the direct sampling radios. So this is the top 25. And of those 25, I've run 20 of those rigs in a contest, at least one. And as I say, I was spent 3 months running the new Yaesu, so get a lot of time on the air. But look what you can see there. Right in the middle is a 100 dB radio. 20 years ago, you couldn't buy a 100 dB radio. So the choices today are astounding, from 110, and you said, do I really need 110? Probably not. Clear down to little KX2 at 86, amazing little radio. So your choices are unbelievable, and the prices are all over the map, from $900 to over $12,000. So the sky's the limit. So how are you going to pick a new radio? Well, I'd say, why don't you just pick something out of the top 25? If you've been with an individual brand and you say, I'm an ICOM guy or Yaesu guy or whatever, fine. major OEM has a great radio from the standpoint of laboratory numbers, so pick one that fits your budget. As I say, the price range is all over the map. What is really different is the ergonomics, the user interface, the menus. So it's very subjective. What works for you? Maybe it doesn't work for me, or maybe what you like, I don't. So you just really, if you can sit down in front of a radio, that'd be a great advantage. If you like ham radio outlet, of course, we've only got about 10 of those stores around. Luckily, we have one in Denver. The other thing is, in an urban environment, noise is a big problem. When I moved to Denver in 1969, noise just wasn't an issue. Now everything's electronic, making a racket. So the noise mitigation may be a big deal in an urban environment. You might pick a radio that has what's got the best noise blanking or noise reduction. And that's subjective, of course. And your noise isn't going to be the same as my noise. Again, antennas are important. Here's the list that I consider of importance. Location. Now, you're probably not going to move. I did. Antennas. Emphasize your antenna if you can. Operator skill. I need more CW skill. And then the radio. I'm not saying the radio is not important, but consider what's the most improvement for the least money. Maybe it's a better antenna. Okay, this is going to get kind of techie nerd. This is the 7 direct sampling radios as examples of how they're different and how you need to understand what your radio is compared to another. So if we look at the right-hand column, we've got the dynamic range. And dynamic range means, can you work a really weak signal surrounded by strong signals? And that's the ability of the radio to not produce its own interference. So these numbers are all pretty much around 100 dB, which is phenomenal. Now, the thing is that all the direct sampling radios that have an analog to digital converter chip, it's too noisy to just use by itself. Now, it would work on 80 or 160, but if we're on 10 meters, let alone 6 meters, you've got to have gain ahead of the ADC chip. And the amount of gain, exclusive of a preamp that would be adjustable, is all over the map, but depending on which company decided to make their standard. So for instance, with the Flex, the noise floor, that would be a CW noise floor measurement with no preamp. Of course, they've got plenty of preamps, but just the way it is fairly insensitive, with a noise floor about equal to band noise on 20 meters. Of course, you can turn a preamp on. The Elecraft has about 10 dB more gain without a preamp than the Flex. And then look at the ICOM, has like 12 dB more gain than the K4. So the noise floor, or consider it sensitivity in another term. Sensitivity I use for sideband, noise floor for CW. That they're 22 dB difference in how the radios are without a preamp. So you just have to realize your radio may be totally different on what's appropriate. So if I'm on 20 meters with a Flex, I'm going to need a preamp. The same time with an ICOM, I would never use the preamp, but I need to use the attenuator on the low bands because it's way too sensitive. So this is just, they're different. They're not right or wrong. They're just the design that came out of the factory. So current offerings. This is totally subjective on several transceivers that are relatively in the last few years. So this would be observations made here at my QTH, where I am right now, during contests and just general operating. So the main architecture types, to remind you, hybrid superhet, direct sampling, or the ones that have still a superhet, but they're a direct sampling once we hit the first IF. The most user interface today are some sort of an LCD screen, either internal or a separate screen. I just use the internal ones for all of them, but some people have 2 or 3 enormous screens, and that's great, whatever you like. Now the Flex radios run on Windows or Apple. The Apache that has the pure signal, it runs on Windows only, except their newest offering is called a G2, Generation 2, and it runs on a Raspberry Pi. So that's different than what we've had until just recently. One thing I find that's annoying, if I'm running my radio with a computer and Windows in particular, is Windows updates can break things. So in other words, it'll be working fine, and then the update comes along and suddenly I go to FT8 and it doesn't work. So the other complication is Windows or even the Apple OS is not a real-time operating system. So you might be on the air and your computer decides to go run a scan of your hard drive or go out and update your antivirus program. So this can be an issue. The other radios are standalone and they don't have that issue. But how you interface is up to you, but you might consider having just a separate computer if you're running a computer operated rig just for your radio. So let's look at what's available today, and that's come out since 2020. And the top half of these were in that time period. The price range is all over the map. The K4D with a tuner, because almost everyone has a tuner, that's an option in the K4D or the K4, it's almost $6,500. And then we've got sort of bargains today. Look at the Yaesu FTDX10, $1,400. The ICOM 705, $1,350. The little Yaesu 710, two versions of it, with or without an external speaker, $900 to $1,000. So the bargains today are amazing. And then, of course, there's the used market. So then the other ones on the list are the other more flagship radios, and they're in the $3,000 to $4,000 range. So let's make some comments on individual brands or models. Flex has had some military contracts, and of course they really started with the 6700, which was a spinoff of a military contract. So they've been busy with that for the last 5 years or so, and also emphasizing remote operation and contesting. There hasn't been a lot of digital signal processing changes at Flex in that time period due to their military contracts, and there are some bugs that have been around a long time, but the Flex has a very loyal customer base. There's no documentation though, so you can't get a schematic or a service manual, and that I find annoying. I'd like to at least look at the schematic. Currently, they've got radios that are M and non-M. In other words, the M model has a built-in display and knobs and all that. So the non-M models are shipping now again. The M models will ship this summer, according to Steve Hicks. And then the Maestro actually should have just started shipping again this week. And they said it'd take a few months to fill the backlog. So they've had to catch up due to supply chain problems. Apache, that's probably the smaller of the big six. They have the best noise mitigation, noise blanking, and noise reduction. And it's one of two brands that have this pre-distortion to reduce splatter. But I consider the Apache a fiddler's delight. It's not plug and play. So if, let's say you just recently passed your general, or maybe you're even operating as a tech on 10 meters, and you want an HF rig, I don't suggest the Apache for your first rig, and I also don't suggest QRP for your first rig. Buy a 100-watt standalone radio that just needs power, a microphone, a key, and an antenna. The documentation on all the adjustments in the user interface on all the menus is rather incomplete. Some I haven't the slightest idea what they do on the Apache. One company in Australia makes the radio and they write no software. It's all open source. Warren Pratt, NR0V, who lives about an hour from me, writes all the DSP code, including the pure signal. And a separate computer may be a good choice. Comments on the 7300. Now, I consider that a game changer, not because it was the best radio ever made, but it changed the direct sampling world 8 years ago. It was the first time you could get direct sampling in a box with knobs, and you just plugged it in and it worked. You undoubtedly know that if you get on the air and Rag Chew that you're going to talk to a 7300. There's over 50,000 sold just in the United States and Canada. It's got a good dynamic range, just a hair below 100. The 7300 operates much like the more expensive 7610. The ergonomics are good. The scope is small. One thing with the ICOM is they have a common interface. They're not exactly the same, but the 7300, the 7610, the 9700, which is the VHF UHF version, that's and the 705, they all work about the same way. So about 2 years ago, ICOM improved the scope with something called a scrolling feature. So when you're tuning to work the next station in a contest, for example, you use a cursor so the screen doesn't smear when you tune it. Without the scrolling feature, I found the waterfall almost useless. But since they added that 2 years ago, it's just fantastic. Firmware is stable, but the 7300 does not have an audio peak filter like I explained with the Kenwood and the 7610. The latest firmware is 1.42, but that has something to do with the PW2 amplifier that hasn't shipped in the US yet. So if you have a 7300, I wouldn't bother trying to update the firmware. No point at the moment. Wait till we know more what's going on there. Comments on the Yaesu FT710. This is Yaesu's first pure direct sampling transceiver. It's similar to the 7300, but the lab numbers are better, and you would hope so. It came out 7 years after the 7300. So here's what your options are. On the 710 AES, it has an external speaker. Now I like the external speaker, but I don't like mixing the internal speaker with the external speaker. There's a panning adjustment, so I just pan it all the way to the external speaker, but that's up to you. The 710 Field doesn't come with the extra speaker, and it's $100 cheaper. If you use headphones all the time, why not save $100? The 7300 is still $1,000, and the FTDX10, which is the superhet with direct sampling at the IF, $1,400. Probably for a CW pileup operator, I'd pick the 10. The user interface and the band scope, I wish that was a little more refined, but you get used to it. I spent the fourth quarter of 2022 running contests with both the 710 and the 10. I tore down the rigs at operating position 1 and 2 and ran the Yaesus for all that entire 3 months. CQ Worldwide CW and the AWL contest, the 160 and the 10 meters. And it really spans the gamut from low frequency, noisy bands to quieter bands with a longer skip. The FTDX10 came out before the 710. Excellent lab numbers, hardly anything different from the 101D. The ergonomics are different than the 710. Again, the user interface to me is a little clumsy, but you get used to it. So the 10 is that IF direct sampling. In other words, it's a super het with roofing filters, but as soon as we hit the first IF at 9 megahertz, we're ADC direct sampling. Both the 710 and the 10 have an audio peak filter. The 7300 does not. So like I say, I ran all these contests over that 3 months, including Stu Perry, top band 160, and I only ran the 10 because it was easier to adjust the CW bandwidth with just a knob. So sitting in front of the FTDX10 and the FT710, it's almost like they were designed and manufactured by different companies. Adjusting the filter bandwidth in the IF shift is easy in the 10, dual concentric knobs, not so flexible in the 710. The 10 has the volume control very close to the VFO on the left side of the VFO, and so if you're right-handed, you tend to bump the VFO, adjusting the volume. But of course, you can get used to it. The 710 has the less crowded buttons, and it has some of the buttons on the top edge, so its ergonomics as far as just pushing buttons is a little simpler on the 710. Unfortunately, if you're using a fairly narrow span, like in my examples of 10 kilohertz for a contest, I want to be able to work every station in that 10 kilohertz and then go on to the next 10 kilohertz and have it recenter the band scope, but it does not on the Yaesus. So I found that was a time waster. The Kenwood TS590, that used to be the best bang for the buck when the 590S came out in 2010. And then 4 years later, the SG came out. It's an excellent radio. It has no band scope. Not that you can't add one, but that's the sort of the transition was that time period. Reasonable price. Used market even better. Very easy user interface, not too complicated. I've operated both the S and the SG in 160 meter contests. And I believe it was when I was running the S, I also ran the Ten-Tech Eagle at the same time. So in that case, I had two different radios I was evaluating at operating position 1 and 2. Will Kenwood bring out a new rig in 2024? I wish I knew that. The 590SG came out in 2014. The 890S, which is an excellent radio, I owned it for several years, came in 2018, so it's good. Time's ticking away. I really like the waterfall best of the 890S over anything else, but I do like the ICOM. It's just a hair below as far as efficiency. The TS2000 was discontinued, and that was its sort of DC light radio. It's 160 meters through 70 centimeters, or with an option 23 centimeters. So it got discontinued several years ago, but with no replacement. Last year at Hamvention, the new walkie-talkie from Kenwood came out, the THD75A. I don't know much difference between the 75 and the 74, but it's very popular. So whatever happened to the competitors to the 7300, the 9700, since the 2000's gone, I don't know. 10 watts in a battery, summits and parks on the air. Do you like to do that? Do you work them from your home station, or do you like to go out in the field? So if it does interest you, one rig to consider, assuming you don't want a 100-watt rig with a big battery, it would be the ICOM 705. It works 160 meters through 70 centimeters, sideband, CW, FM, digital FT8 with a laptop, of course, and the price is reasonable. It also has an optional tuner that runs on batteries with locking relays. That's $360, and you could just have a 23-foot piece of wire, throw the wire up into a tree at a park or someplace, and work 40 meters through 6 meters with the touch of a button. I worked a 705 that was running Parks on the Air in the Colorado mountains, New Year's Day of 2023. The guy was S9, 2-meter sideband, and it was 100 miles away, and it was just like he was sitting in the room. It was tremendous. So here's what the 705 looks like. It only weighs about 2.4 pounds. The 7300 by comparison is just a little under 10 pounds. And it's even got a speaker in the front pointing right at you. So it's a quite very nice radio, and I've run it in a couple of contests. So comments on the 705. It's a 5-watt radio with the internal battery and a 10-watt radio with an external battery. It operates pretty much like a 7300. Of course, there's all sorts of things that it has, like D-Star, that I don't use. But if you can run a 7300, you can run a 705 with your blindfolded. Lots of VHF features. The screen size is the same as like on a 7300. And it's like I said, the interface is the same. All the current ICOMs pretty much work the same as far as the user interface. And it does recenter. So if I've got it set up for the contest that I ran in 2020, the ARRL 160, ARRL 10 meters, to whatever span I chose at a given mode or how active the band was, once I've covered every station that I'm doing search and pounce, I go to the next swath, it recenters all by itself. Really nice. Comments on the K4. Much of the firmware that ran the K3 got ported to the K4. In the last 2 years, they've made significant strides in their firmware. When they first shipped, it was a mess. So the firmware and features are still under development. You might go to some feature like general coverage and it says not implemented yet. And every time a beta software, beta means test software, and once it's out for the general public to play with and to find bugs, there's bugs. The AGC threshold is still kind of strange. And matter of fact, Wayne just said yesterday that they're going to make an improvement in that. It's because the audio level is sometimes inadequate, but maybe this new update will fix that. Excluding the $10,000 rigs, The K4D is the most expensive mainstream rig. As I said, it's almost $6,500, and where most everything else is in the $3,000 range or below $2,000. There was a price increase of April 20th of 2023, but there's discounts at a lot of festivals. Maybe there will be today. The HD model, which would be a super het, would be like the direct sampling at the IF. Hasn't been out yet, although it's in development. Pre-distortion has been talked about, but still not available. And the transverters. So there's things to come for the K4. The customer base is likely mostly past K3 owners, very brand loyal, tremendous support, and also N6 TV Bob, tremendous support on the reflector. The only thing that's really odd about the K4D or the K4, if you've only got a single antenna, let's say you've just got a tri-bander 10, 15, and 20. Well, let's say your working station's on 20, but you want to see if 10 meters is open. You can't do that with one antenna. That's just odd. But that's the way it is, because the transmit low-pass filters in the circuit on 20 meters, and you're trying to listen to 10 through the low-pass filter, it doesn't work. Comments on the 7610 versus the 7300. Well, the 7610 now does have digital pre-distortion. It came out Thanksgiving Day last year. The difference is people who send me emails or call me up on the phone, should I upgrade from the 7300? So what's the difference? There are no noisy relays for the TR switching or the amp key line. And there is a relay for that, but it's an option. You can use a FET. It does have an audio peak filter. The 7300 does not. It's got dual receivers, of course. So for DXpedition split, every DXpedition runs split. It's handy, not required. You can certainly work split with the 7300, but it's easier. Many more physical buttons and a larger LCD screen. There's a button for each band instead of having used the touch screen. There's 2 transmit ports on the 7610 versus 1. It has a receive-only port for like a beverage. It does have a video output. If you want to put a 47-inch monitor on it, you can. The fan is quieter, no question. The second receiver is really only easy to use with their RC28 external tuning knob. It's kind of expensive, but the flex knob is expensive, and the Elecraft knob is expensive. They all cost about $300. So this firmware update from Thanksgiving 1.40 added this digital pre-distortion, and it works. Now at the moment, nobody knows how to make it work with an external amp, but I'm running tube amps, and the improvement is dramatic. If you only work sideband and FT8, it'd be hard to argue, other than the fact that you'd like new radios. The 7300 works just fine. The 7610 costs 2.5 times as much. This is just a quick look at using the split for a contest. This was the Swains Island. I was on 12 meters, and so I was able to be seeing the transmit frequency range and the receive range. This was the Timor East with the 7610, and again, using the split double receivers. So important factors to consider. Don't select a radio on one number. That's the thing that I've sort of created this monster. All these 150 radios are listed by close in dynamic range, which is important. It's not the only thing. So if you've got operator fatigue from noise or AGC that doesn't work right, that's annoying. Noise reduction and noise blanking could be very important to you. I would say for remote operation, which is now being more and more popular because it's so noisy in an urban environment, Flex may be the best for that. It does, though, have to connect through a server, and occasionally that goes down. As far as Apache has pure signal and some amazing noise blanking. Usually in a contest, you can't use a noise blanker because it false triggers. Not so with the spectral noise blanker in the Apache. Both require either an internal computer or an external one. And the ICOM digital pre-distortion we don't know how to run it with an external amp at this time. Other things to consider. Bad ergonomics, or at least ones that don't work for you, can be frustrating. Does the speech processor work? Well, for instance, when the K4 shipped, speech processor didn't work. EQ didn't work, but that's been fixed. Do you want a standalone radio, or do you want to run it with a computer? Personally, I want a standalone radio, but that's just me. Is the firmware updated? I mean, all these radios can update firmware, but if they don't bring out any new updates, fix bugs, or add new features, then that's sort of too bad. What about warranty service? This can be a big deal. Everything's surface mount components, I can't even see them without a magnifying glass. For instance, Kenwood used to have 2 facilities, and one was in Virginia that was really good. That got closed down. The one in California was terrible. And so that was a big problem. Well, they eventually fired that company. They have a new company in New York. It's been out a couple of years now. Does a very good job. So warranty service is important. Is your radio supported with parts and service when it's out of production? And that's sort of a question mark for the K3, because obviously the K4 is announced 5 years ago. So parts for a K3 may be an issue. And the bottom line, do you enjoy using your radio? This is a hobby. It's supposed to be fun. And so if your radio is a struggle, try something else. And something that you like or your friend likes may not work for you. So it's just very subjective. I'll send your club a PDF of this. If anyone wants a copy of that, they can also email me, rob@nc0b.com. I'm going to quit sharing and see if we have any questions. So those of you in the audience, hello, and fire away if you have anything you want to ask. Do we have a moderator?
Yes, we do.
Okay. Anybody out there, wave your hand.
Yeah, go ahead.
Can you hear me from back here?
Yes, I can.
On Flex, the Flex iPad software is like operating a radio.
Yes.
Can you justify spending $1,500 for the Maestro when the iPad seems to be just fine?
Well, it's pretty expensive considering it costs more than the ICOM 7300 or the FTDX 10 or et cetera, et cetera. So it seems kind of expensive. It's been out of production now for a long time, but they're just shipping it again. So that's just personal. But a lot of people are very happy with the iPad interface.
Thank you.
Anyone else? Is there anybody online that has any questions?
Yeah, just unmute if you do.
I have a question.
Yep, go ahead.
I'm just starting, and I'm about to buy my first radio, for W and SSP. I definitely want to operate, 10 meters down. Is there something you want to recommend so that I don't spend a fortune on my first radio and hate it?
Okay, well, that's an important question. I don't think anyone who's new to the hobby should go spend $4,000 or $5,000 for their first radio. Hopefully you're going to be a ham operator for the next 10 or 20 years. So I would stay in that price range below 2,000, and really there's nothing between, as far as I know, between 1,400 and 2,000 out there right now that's brand new. So I would say look at those radios that were on the list that were between $900 and $1,400. And they all work really well. They're different from the user interface. That's the biggest thing I can't underestimate is the way that the user interface and the menus and the adjustability and the knobs and all that, or whether you have to go into a menu to make a simple adjustment, is very much different. So if you're considering a radio, and I would get something between $900 and $1,400, is if you can find a friend or someone in your club, if you do happen to have an HRO nearby, make use of that, because it's very subjective and it's very personal as to what's going to make sense. But those radios I talked about today in that price range, you can't go wrong. They're just going to operate differently, but you won't say, I missed that DX because the radio didn't work. That's not the case.
What was the website?
Rob, could you give us the URL for your website?
Sure, it's real simple. There's a couple, but the easy one is nc0b.com. nc0b.com will get you there. And if you want to send an email, rob@nc0b.com.
Any other questions?
Okay, very good. We'll enjoy the rest of the HamCon, and we'll let the next presenter connect in and go from there. 73, everyone. Thanks for attending.
Thank you.
everybody online.
Okay, don't know why that happened. So, there we go. Okay. So you get, if you're in St. Albans or somewhere way up north, you can have totality for like 3.5 minutes. The further away you get from that, the less time you have. And there's a partial phase before and after totality. There we go. Here's the path. The eclipse starts out in the South Pacific. Oh, look at this, it works. Goes across, hits Mexico. When it hits Mexico, that shadow is traveling at about 1,500 miles per hour. Zoom it across the country. It goes through 12 states before it hits us in Vermont. By the time it hits us in Vermont, it's traveling like 2,600 miles per hour, which is why it lasts only 3 minutes. And by the time it gets to Newfoundland and out to sea in the Atlantic, it's 4,000 to 5,000 miles per hour because of the curvature of the Earth and all the geometry of the orbits. But it'd be a great thing. If you miss this one, the next total eclipse in Vermont won't be till 2079. So let's hope we see it. Yeah, we'll see you there. There's a little more close up of the path. If you are within these two blue lines, you will see totality. Anywhere outside, you will see partial only. So you can see the dead center line goes right through the top of Vermont, just barely. There we go. So again, there's a center line, there's a lower limit. So if you're in Middlebury or Barrie, you better head north. Anything below here is partial. Bennington, for instance, will see a 96% partial eclipse, but that's it. So and I've never seen a total eclipse. I've seen several partials. The people I've talked to have seen total eclipses say it's awesome, it's moving, it's spiritual, nothing like you've ever experienced before. Because all of a sudden the sky goes dark and you see the sun goes away. Pretty cool. Here's some timing you can see. So up here in St. Albans, 3 minutes, 34 seconds this way. The further away you get, the time drops for the amount of totality down to 2.5 minutes, 2 minutes. If you're on this borderline here, we're talking seconds of totality and then eventually no totality. So they expect a lot of people to come to upper part of Vermont. You know, roads could be blocked. People are saying stay off the interstate because you don't know what's going to happen. It's going to be, could be a mess if it's clear. Yeah, people have asked us in the club, why did you schedule this for a Monday afternoon? We wanted to. Where to look? I got things here. I got to get rid of this. I guess I can't. Southwest, basically. If you have a clear view from your house to the southwest part of the sky, about halfway up, then you can see totality. You'll see the eclipse. It'll start about 49, 50 degrees high. It'll drop down during when it's total, it'll be 40 degrees and drop down to 30 because the earth is turning, the sky is moving, the sun is going down and all that. But somewhere that has a good western southwest horizon would be great to be at. I didn't take this, but I wish I did. And what it shows is as the sun is moving across the sky, because the earth turning west to east, the sky moves east to west. But the moon, relative to the sun, is moving west to east. That's why it starts here on one side and slowly creeps across the face of the sun, blocks it up, and then creeps off the other side. Because as the sun's going this way, the moon is slightly going the opposite direction. Pretty cool stuff. This is what we hope to see. That is not the sun. You are looking at the dark side of the moon. Hopefully that's what we'll get. If it's cloudy, it's going to get dark, probably darker than if it's clear out because it'll all be a dark sky because of the clouds. Don't miss it. Even if it's cloudy, go outside.
That can't be the dark side.
Do you see any light?
No, you can't see the dark side of the moon.
That is the dark side of the moon. Today.
That's the same side we always see.
There's always a light side of the moon and the dark side of the moon. We always see the same side of the moon.
Right.
On the new moon, it's dark because the sun's hitting it from the other way because it's almost in front of the sun. So depending on where it is in orbit, you see partials, you see half, you see gibbous moons. That you're looking at the moon.
And
The-
it's not
the-
gonna be totally dark, so you see it earth shine.
No, because if you're in totality, there's no sunshine hitting the earth where you are, bouncing back.
No, that's plenty of sunshine.
Okay,
I've seen
cool.
it.
I stand corrected because I've never done it. This is the corona, the outer atmosphere of the sun. It's like a million times fainter than the surface of the sun, the photosphere. It's the photosphere is just too bright. That's the part you don't want to look at. Anytime during the partial phase, here or this side, you need a viewer, either glasses, pinhole projector, or one of these, which is the viewing material just in a cardboard form because it's easier to pick and look and share with somebody. They don't have to worry about putting it on their heads. If you do not have one, I will give you one. See me after this and I'll give you one. Free. I could sell for $10. No. Anyway, during totality, you don't need this. You don't need anything because if you try to look through this, you won't see it. So only during totality can you look just with your eyes. This is a planetarium program called Stellarium. It's free to download to your computer. I put in a date and time. So right in the center, and you probably can't see it very well from where you are. There's the sun eclipse right there. Here's Venus. Here's Jupiter up here. Come on. If we're lucky, there'll be a comet right about here. Comet, I forget the Pons or something. Anyways, there may be a comet visible. And you may see some brighter stars. Down, if you have a low horizon, Saturn and Mars. So you may see some planets, may see some bright stars. There's a member of our club who went out to California years ago, and that eclipse lasted 7 minutes. It was a very good eclipse. He said it was so dark you could see the Milky Way. That's pretty dark. That's pretty cool. It won't be quite like that here. They say around for this eclipse, it may look more like twilight, dark, maybe dark twilight. It'll be dark overhead. The horizon, you'll see light around the horizon. It'll be really weird. The whole thing of getting dark at 3:30 in the afternoon is going to be strange. There are very varied filters you can use. Like things like this can go in the front of your telescope. They can go on your binoculars. Of course, you get the glasses that are everywhere these days. We bought this. This is a welder's glass shade 14, which I have used in the past. The club is not recommending them because of controversy as if they're really safe or not. So we're just avoiding that altogether. Now, this is what if you get a filter, if you have a telescope, has to go on the front of your telescope, the front of your binoculars, the front of your camera, whatever you have, it's got to be on the front. If this one, on this telescope, they took the little finder scope off because I had one on my scope, and even though I had a cap, when I wasn't looking during a partial eclipse, the little guy went over, he tried to look through it. If he had taken the caps off and looked, he would have burned a hole inside. So just take those things right off. And then, again, this is our viewer, and glad to give you one. Partial phase, you need filters, front and after, but not during totality. Can't wait to see it. One of our club members, he's the chairman of our eclipse committee. He's been doing presentations with me, and he's advising folks, if it's cloudy, go outside anyway. Go near the woods and see how the animals react. Watch the birds go to rooster, whatever they do. You know, your pets may react a certain way. Cows may start to come home and all that. You know, the animals do react to the sunlight going away. I probably will. I don't know what I'm going to do. Okay. Why am I talking about ham sci? Yes, I'm a ham. Yes, I have a license. You probably never heard of me. I have a rig in my car that I rarely use, but I can't get rid of my license. I just liked it too much. There's two reasons why I'm here doing this. being president years ago, I started a little program called the Presidential Brunch, where I would, every month at our meetings, I'd pick a name at random and have brunch with whoever member I picked out to get to know, is the club doing what you need them to do? Are you learning what you want to do? Are you having fun? Tell me about yourself. Do you have a scope? You know, the whole thing. Just have a good time. Well, I had one with a hamstronomer. And I'll tell you why this person is a hamstronomer. The other reason is I mentioned this ham side thing at the January Randv breakfast. Next thing I know, I'm signed up to do this. So, am I an expert? No. I thought it was very interesting. Ham radio is being used to determine stuff during an eclipse. I brought it up, and here I am. This is Mary Lou West, KC2NMC, and that's me. We're having our presidential brunch together. Having brunch with somebody's grandmother who knows way more than I do was a lot of fun. She is a retired astrophysicist. So she knows a lot about the sky, science, and everything from Cornell, Columbia University. She's into meteorites, cosmic rays, galactic structure was a whole big thing all by itself, physics education. And she said she worked regularly with students on research projects. And after retirement, she's still doing that. And now some of her students is her boss working on the projects. That's kind of cool. So we got to talking about it. HamSci, Ham Radio Science Citizen Investigation. The purpose of promoting advanced scientific research using amateur radio activities. Cool. And encourage the development of new technologies and provide educational opportunities to the hams and anybody else who wants to know. What a great idea, using ham radio for science during an eclipse. They are going to have festivals of eclipse ionosphere science, festivals, activities. They're going to do ham activities to investigate what happens to the ionosphere due to the eclipse. They're going to have multiple events and science research from multiple U.S. universities, like these guys, some of whom they have apparently ham stations at their colleges. I don't know much more than that, but no. So there's a lot of smart people interested in this, and they want ham radio help. So they're going to have contests using 6 to 160 meters. They're going to do research, events, space. This is confusing. Is it personal space weather station, or is it a personal space weather station? I think it's both. And then additional events along the way. So let's talk about some of these. They're going to do a contest, the Solar Eclipse QSO Party, using CW, FT4, SSB, and other stuff. And then there's going to be a signal spotting challenge also. And there's rules and regulations on how to do this and how the format and all that. So the Solar Eclipse Party. Oh, there's another activity. I'm sorry. Time delay of arrival. I'm not really sure what that's all about and how you determine that, but there's descriptions on the website about this. I'm not doing this myself because I'm too busy doing other stuff during the eclipse, but all the explanation of what to do is on their website. And then there's the Great Personal Space Weather Station. Great Radio Amateur Propagation Experiment. That's a mouthful. So you can get these grade 1, grade 2 IF receivers to do this experiment. It's a long-term experiment where you monitor the stations well before the eclipse, during, and well after. So you need a baseline of before and after and find out what happens during it. Then there's the medium wave recording event, where you're recording using software-defined radios, broadcast station emissions, and to see what effects the ionosphere has during the eclipse. And there's a VLF reception exercise. They're still trying to figure out what that is. So the Solar Eclipse QSO Party, it's like a ham contest. It's called CQ with SEQP. and you make contact real quick and you try to get a lot of them and get signal strengths and all that. And they did it during the 2023 eclipse, and they're going to do it again this year. They hope to get a lot of data points. So they say millions. Let's hope they get millions. So they need a lot of activity, a lot of input. It will take place on April 8th. It'll start about 3 hours before the eclipse process begins way down in Mexico. So they want to have a baseline before and operate during the whole thing and then afterwards. If you can't operate during the whole entire eclipse, then try to pick a time when it's closest to you, when totality is closest to where you are. Oh, that's what this says. Nearest to your QTH. This website, greatamericaneclipse.com, is really cool because you get on there, they have an animation, shows the eclipse shadow on the earth where it starts in Mexico, travels across the country, and it shows you the time, the speed, and the shape, because it changes, because it's distorting as the earth is curving, this thing distorts along the way. And it's a real cool thing. Who should participate? Basically, everybody. They're really interested in getting folks of the US, North America. But again, radio waves act like they do. They'll take input from hams all over. The more information, the better.
Well, I have a question.
Yes.
About what time is the totality around here? And
326.
well, the sun's down in Europe. So if you're on 80 meters, you might get people in Europe.
Cool.
Yeah.
They want to know that.
Yeah, so, and they'll be on. Yeah.
The ionosphere is gonna.
Yeah. Yeah. Personally, I don't know how it's going to react, but it should be interesting to find out. Yeah. Some requirements. This is kind of seemed odd, but they want all your equipment within a 500-meter circle. So I think that they do that because remote operations permitted, but they don't want you spread out way too far. So 500 meters is quite a ways. Portable, is welcome and encouraged, like going to the parks or wherever. No provisions for mobile. Too many variables, I assume, to deal with. So, any way you can just get on the air. It's like a social mirrors, a contest. Make as many contacts as you can. QSOs, they want them short like this. Signal report, grid square, and that's pretty much all they want. So you can do more contacts to get more data points. And there's a whole format for logging, which I won't get into, is too involved, but you should need to log your reports, your contacts, and then you send them in and they do whatever they do with them and figure things out. Again,
They probably want real signal reports, not 5.9.
this is what on the website, so that's what I put down. So there's a whole list of rules and things to go to guide you on this. The date and times we talked about, requirements, the different bands, the exchange, scoring, and logging your information. So I can see where this could be a really busy time for some folks. The signal spotting challenge using WSPRnet, PSK reporter, and reverse beacon network, which I knew nothing about until I saw this, for the purpose of ionospheric sounding. So if you, on the website, if you click on those three things, it'll bring you to different sites. WSPRnet. Amateurs using digital mode to probe radio frequency propagation conditions using very low power. That's interesting. And if you click on there, you go to that website. I'm not logged in. I didn't log in, but you log in, and then however that's used to log your information. And then the PSK reporter to automatically gather reception records of Digimode activity, make those records available to whoever's interested. And there's a map that shows activity at the time I looked at this. This can be expanded, so you can expand it right out and see what's going on in New England or Vermont. There's very few little bubbles there, but it shows you the activity that's going on. And then there's the reverse beacon network. Stations listening to bands reporting what stations to hear, when and how well. And you click on this thing, it says, try it, and it comes up with this nice map showing the links that change. This was on my machine for a little bit, and all of a sudden, those connections changed as people were picking up and receiving and detecting other stations. So that's kind of a almost real-time kind of reporting. There are places to go. The hamsci.org is where all this stuff came from. Again, I heard about it. I thought it was a neat, interesting way of involving ham radio with an eclipse. The average, on average, for any one location on Earth for a total eclipse to occur is like 375 years. In Illinois, they got lucky. They got 2017 and 2024 paths crossing in the same place. That is really rare to happen. There's going to be another partial eclipse we'll see in 2 years. And then there's a total eclipse passing through the bottom of the country in 2045, I believe it is. We'll see a partial. So, but again, the next total eclipse in Vermont is not until 2079. So all these sites gives you all the information. The eclipse 2024 and Great American Eclipse. The 2024 site will tell you it'll give you a simulation of what the eclipse will look like anywhere in the country. So you go to Vermont, because we're in the path, you can pick any city in the state, and it'll show you what it's exactly going to look like. It's really cool. My warning, don't miss the eclipse to do radio. If you want to be involved in this, if it's a clear sky, find a way to be outside to do something, or just stop doing it. Don't miss the total eclipse. Again, and if it's clear, if it's cloudy, go outside and experience the darkness anyway, because it's a really, really rare event. And I'm really looking forward to it. I think that's all I had, really. I know. Question, yes.
So there's that experiment to do the QSO party for the eclipse.
Yeah.
Is there any, based on past experience with radios, is there any expectation that some bands will be better or worse, or do you know?
Personally, no, but at the breakfast, there was at least 2 people who were involved with the 2017 eclipse with the hamsci experiment. So I don't remember what the names were, but Mitch. Someone else who volunteered for the talk did too, and I can't think of his name.
Yeah, Mitch is gonna get on 80 meters during it. I don't know if he's gonna go out and watch it, but he's gonna get on 80 meters.
I mean, it should be, I imagine it's gonna be an abrupt, weird change of some kind.
Yeah, I'm David McGaugh, knowing everyone in the tell Charlie. I'm actually part of college connection to Hamsci.
Yay!
And the changes to the ionosphere are dramatic as it goes over. So it goes basically from daytime propagation to nighttime, and then rapidly changes back. And we've done this and a number of eclipses, but in the United States, we had the 2017 one. We had the one back in October, which was a partial, but it was deep enough that it had dramatic changes. That was an annual, but it was like 99% gone. And it really is quite striking how 20 meters disappears, 80, 40 come in. And and one of the things we say is, even if you don't make a contact, put the signal out there, because we do have the reverse beacon network and other receivers out there listening. And a non-contact is useful information.
Thank you.
Cool.
And the Gladstone Signal Spotting Challenge, that's an interesting name. Gladstone is the one you started, I think ESA reporter. Anyway, the idea is that you can either be listening or transmitting. Whisper, you can do FT8, the 4 version. I don't remember the letters.
FT4.
Well, it's not FT4. There's something else that's like a super whisper. But you can either be transmitting or receiving. All of that information is going to be useful to the project. And I do agree with him. If you're in the path of totality, stop transmitting and go outside. It's going to hurt you bad. The changes to the ionosphere are much less. You know, you missed that 4 minutes. Yeah, don't miss that 4 minutes.
You know, if you're operating a vehicle, pull over.
Right.
So is that a Monday?
It's a Monday.
I'll be down or I'll probably back into the Wilson by 3 o'clock.
Yes,
So
yeah.
I could set up my station and whisper on the meters and just leave it out.
What's the deal with Whisper? I know that a couple of years ago when I read about it, I tried to buy the Whisper device from Sotheby's in England or whatever, selling the transmitter. And they were out of stock, unavailable.
It's your own radio and your own antenna. You don't have to, I'm not sure what you're talking about, but you just download the program.
Oh, so you don't need to buy the special tool for.
No, download the program.
The idea with those is it's standalone, you don't have to tie up your rig to it, it could just be running these videos. And as it's mentioned, it's very low power. You know, 1 watt or less.
They've been unavailable.
But there are lots of different versions of it. Tapper sells one. There are other ones. Actually, there's it's an Arduino version that it just uses a digital output on the Arduino that produces the same.
You can set up normal HF radio to transmit it.
I think I felt it.
You don't use the down card modes now, like FT8.
That's
ESA 31.
WSJT that program that we use for FT4 and FT8 also does Whisper. Both transmit and
Yeah, it's automatic. I thought it transmitted, kind of like FTA, like bing, but it does transmit like every, like 5 minutes?
Well, Whisper is a 2-minute cycle.
Right, it's 2 minutes transmitting?
Yeah.
So it's 2 minutes transmitting.
2 minutes transmitting, but usually 1 of 5. So, well, you can have a switch frequency, usually leave it on frequency, but it'll transmit for 2 minutes, and then it'll be down for 8 minutes, and then it transmits another 2 minutes. So other areas come in. One of the simplest things to do during this method is put your receiver on Whisper Receive. The WSJT software automatically uploads your spots, and you can just walk away from it and let it run.
Cool. At the 2017 eclipse, I was at the library in Jericho. It was only 50%, 55% coverage. But even with that, I noticed a reduction in the sunlight, and I felt the temperature change when it was maximum. So imagine the total is going to be even more so. It's going to be interesting.
So just a little story, when I was in grade school, there was an eclipse. And I remember I was in 7th grade, I think there was a ficus tree that my science teacher had his science room. And as it moved through annularity, you could look at the core underneath the ficus tree to see the sunlight change as the sun waxed and waned. You could see it before and after by looking at the core.
Yep.
Just the light coming through and being diffused through the ficus tree.
Yeah, if you
That's
take,
one of my favorite memories from
you
my.
take a sheet or a cardboard or something white, go under a tree during an eclipse, the pinholes through the leaves will create little shadows. They'll all be eclipses.
It was the craziest thing.
It is. It's really wild.
Yeah, bring your aluminum, annual colander.
Well, I have aluminum foil underneath my hat right now.
So I'll also mention, we actually have the ham site workshop coming up at the end of March,
Cool.
which is, it's gonna be at the East Western Reserve in person, but it's also online. So if you're interested in that, or not interested in any of this, go to the hamsite.org website. But you can sign up for the workshop. But, don't quote me on this, I think the virtual might be free. But anyway, it'll be online and a long series of presentations.
Cool. That's great.
2 days, it's Friday and Saturday, March 22nd, 23rd.
We're delivering presentations to a lot of libraries and a few schools and residences up until they're all mostly doing next month. And we got 20 of them just to talk about the eclipse, best way to view it, how to do it safely, and what to expect. It's going to be quite a thing, and there's going to be a lot of people up here. So
A lot of people travel long ways to see it, right?
yeah, I've had people say, "We'll pay you if we come from Boston if you show us the eclipse." I'm busy, sorry. Come on up, bring your money. That's the other thing. The path of totality is also a path of money. Just think of the money people are making on this thing. Oh, that's about all I have. So, any other questions? You can ask him. He knows everything.
Now, let me know if you have any.
Yeah, thank you very much. Glad you're here. Thank you.
You didn't do this. They picked the right guy. That was fun.
No, thanks.
Hey, what about the people online that play?
Oh, I forgot.
Anybody, you might want to chat.
Yeah, anyone online have questions?
There was one question, it said, can you use a sextant if you?
No. A sextant, no. Don't use aluminum foil. Don't use potato chip bags. Don't use negatives. Only use.
I thought you could use negatives.
No, I have. It's not good.
Can I get one for me and my wife?
Here you go. Hang on.
Thanks, I got one.
Thank you, sir.
Okay, hang on. Yeah.
Can I get?
You got one.
You're gonna save everyone's video.
I hope so.
Thank you very much.
Don't want anybody going blind. There you go. If you want. March 4th, first Monday of the month.
That was awesome.
Yeah, thank you so much. I'll come through again. We're gonna grab a.
Okay.
You guys, you're gonna see my speech. Just on me, President.
You can do it either way. It really doesn't matter.
I'll still.